and so forth. But for the lesson, for the exam you are writing, you will need to at least know up to 18 because of fatty acid and glycerol. Do you get what I'm saying? Stearic acid, palmitic acid, oleic acid, these guys, stearic acid is about is hex 16, ndozo 18. Are you getting what I'm saying? We'll get to understand that. Now, but my point is this. Listen. Whenever you are naming an ether, you name these two together. What did I say? Then you name this one. Please, an ether is not the same thing as an ester. Ether and esters, they are not the same thing. An ester is not the same thing as what? An ether. I will talk about it. Ether has oxygen bonded with alkyl groups on both sides. Am I communicating? So, if you are naming it, you attach the alkyl group and oxygen here together. Then you name this one. So, let's do this. This is methyl bar. This is oxygen. So, what are we going to call it? Metoxy. Sorry, did you get the point? What are you going to call it? Metoxy. You should be methyl oxy now, no? Man, I wait for the ale because we are joining. So what is it going to be? Metoxy methane. Metoxy what? CH3O C2H5. What is the name? These guys are named together. What do you have? Metoxy what now? Ethane is 2 now. So 2 means et. Ethane. Communicating. That's ester. I said ether. Ether. How do you name them? This one. Combine them. Call it something. What are you going to call it? Alkoxy alkane. That's how it's named. Alkoxy alkane. If you have metoxy ethane. What if you have this guy? What's the name? Propoxy what now? Methane. Those online, I hope we are following. Okay, did I cut you people off? Well, let me write it at the center. When you are naming, are they following? Okay. When OH class, what is it? Am I communicating? So, but the catalyst or the person or the agent involved is H2SO4, conc H2SO4. You heat it at a temperature of about 170 degrees. Once you do this guy will leave. And these bonds will be empty. Because they are empty, what will now happen? They will now join. What is produced? Double bond. Am I communicating? It's not entering very well. Listen, you cannot see the board. Okay, I clean it again. And I say it again. How you produce your alkenes? Very simple. Remove water molecules from corresponding alkanols. That's how. The agent involved in the removal is conc sulfuric acid. Is what? When you remove water molecule, a water molecule I meant to say, from a corresponding alkanol, what you will get is a corresponding alkene. That's all I'm trying to say. Then see how it happens. C, H, OH, H, bar, H. If I remove this hydrogen here and remove this hydroxyl, these guys will be hanging. They'll be hanging, bar. What is now going to happen? They will now join. If they join, how many bonds will now be there? Double bond. So my point is that the agent required for this reaction to occur is conc sulfuric acid. It is going to remove water molecule in form of hydrogen and hydroxyl. Once that happens, you find out that what is going to happen is the bonds will join, the pi bonds will join. And please, what do you have here? Alkene, alkyne, alkane. Plus H2O. Am I communicating? This is a dehydration reaction. But for this to occur, you have to use excess sulfuric acid. Excess sulfuric acid reacting with alkanol will give corresponding alkene. Excess sulfuric acid reacting with alkanol will give corresponding what? Alkene. But when you see a question and they tell you excess alkanol reacts with sulfuric acid to give what now? Ether. That's all I'm trying to say. Did you get what I just said now? Write it. Don't even get it. Just write it. I've told you both times that number. I know that your brain understands it. The problem is that your sense does not understand it. Yes, your brain knows what I'm saying. So I know your brain. So write it. Write it. Right, everybody. Reaction between an alkanol and excess conc sulfuric acid gives corresponding alkene. Reaction between an alkanol and excess conc sulfuric acid. What will it give? Corresponding what? Alkene. Reaction between alkanol and excess conc weighting sulfuric acid gives what? Corresponding alkene. Is it not? On the other hand, if the alkanol is excess, what will it give? Ether. On the other hand, if the alkanol is excess, what did I say it will give? What will it give? An ether. I'm seeing a question for those that will write. IMT, where are you? There is no IMT this year. Are you people here? Question number 18. I see, I saw. An ether is produced by reacting dash with sulfuric acid. Excess ethanol, insufficient ethanol, ethene, excess ethene. What is the answer? Am I communicating with you? So if ethanol is in excess, ether. If sulfuric acid is in excess, ethene. Sorry, am I communicating? Hope I'm not wasting your time. Let's continue. Yes, ma'am. On the other hand, if alkanol is in excess, on the other hand, if alkanol is in excess, an ether is produced. If alkanol is in excess, what did I say? Ether is produced. Okay, I didn't say it like this. If they are equal, what will not happen? I'm on camera. Why do you want to spoil my show like this? I'm on camera now. I don't know. Sorry. You want to spoil my show like this? Okay. Let's continue. Yeah. Now, the next person I'm going to talk about is name inoquia. Is polymerization oquia? Is isomerism oquia? Now, some of you, listen. Some of you have not, if you did not notice, listen, you should have noticed that, listen, please listen. I have been touching almost every aspect of that thing you have. Small. I've talked about polymerization. I told you that there are two types of plastics. What are they? That's the one that will come out. As I was saying. I told you, listen, that the monomers of bakelite are what and what? And formaldehyde, right? Okay. I've talked about polymerization. When I came to naming, I told you there are three parts of a name: prefix, infix, and suffix. Am I communicating? Three parts of a name: prefix, infix, and waiting. Suffix. Thank you. These three parts of a name, we have talked about the infix and the suffix. Infix is the number of carbon atoms in the parent chain. Suffix is what will tell you what? The homologous series. Don't worry, we will see. Hey, what is the time now? It's to 6. You know why I cannot stop? Listen. What do we suggest? We should come where to what? To do what? Yes. What do you suggest? Continue. We should continue till tomorrow. We should switch to naming. Hi, God. Oh, yeah, it's okay. Listen. Which one? Now, get on to. You know, most of you feel that the most important thing is naming, but listen. I will still talk about naming. Hopefully, the problem we have is not me, it's time. Are you getting what I'm? You know, what I envisaged, was that 6 hours maybe would have gotten to somewhere. But if you notice, I told you that I am not going to be teaching you your contemporary way. I have been giving you studies on practically everything. Are you getting what I'm saying? If peradventure, I said if, we happen to get to a time and it is important that we live here, because in this area, they used to carry gun, not knife. And we need to live here. Are you listening to what I'm saying? I'll see what I can do. It could be, we'll have to talk about it after the class. You get? Because I don't know, unless you want me to create time, I can't keep you here. For instance, the agreement with the center is 6:30. Yes, I told you people now. 6 hours, 30 minutes because of the 15 minutes break. So 6:30, we are supposed to be out of here. Your parents are gonna be calling this center. My daughter went to lesson since 12. Can you not go? Can you not go? Some of our parents are very savage. You get? Uncle Chakwa, they were room 202. My name went 202 in Jesus' name. Okay. And now listen. Let's just see what I see. Listen. Listen. This table is more diversified than naming. That's why I would prefer to finish the table. So let's continue. Naming. Don't worry. MDA students you are MDA students, so we'll have a physical class. If I come physically, you can hold me if you see me. If you see me, you hold me. However, it's possible that we could have just a brief online session on how to name. You are not online. How is it my fault? It's not my fault. Let's continue. Now, as I was saying, get on to. Listen. Get on to. Listen. Let's continue. My point is, it's not about uncle continue or don't continue. Shall you see this one we have done so far? Put it in your head. Let's continue. Should I stop the class? Do you want me to stop the class? The girl in red. Okay, you can go. If you are tired of the class, sorry, I want to stand up and say this one. Hey, it's okay. Those that are online, once they get tired and sleep, they off their data and sleep. Go on, neighbor. If you are feeling too hungry, okay, reprinting is going on at the office. Just in case you want to do reprinting. It's not I'm falling. I intentionally wanted to. I don't know. Okay, now listen. Please, if you feel that you must go now, your parents discuss with you 5:30, start going home. Your parents gave you a coffee 6 o'clock, start doing what? Going home. I'll finish this table. Listen. When you shut up, I'll continue. But that guy that went to buy me biscuits, where is he? Should I continue? Etanoic acid. Alkanoic acid, sorry. Okay, I should do isomeric. Just leave me. I will do it the way I want. Stop. Don't suggest anything to me or sis. You get? Besides, this is my free time I'm giving you people. As I was saying, what did I say? Alkanoic acids. Now listen. Listen. Any organic acid that has, please listen to me. Any alkanoic acid that has 12 and above carbon atoms is no more alkanoic. It is now fatty acid. Side note, or your side note. Alkanoic acids with 12 and above carbon atoms are referred to as fatty acids. 12 and above. Alkanoic acids with 12 and above carbon atoms are referred to as alkanoic acids with 12 and above carbon atoms are referred to as fatty acids. Are referred to as what? Fatty acids. Now listen. Yes, sir. Question. Hold on. As I was saying, alkanoic acids with how many and above? 12. What did I say you call them? Now look up. Look up. Look up. Look up. So if you have an alkanoic acid, functional group is what? Functional group is what? COOH, which is carboxylic. Carboxylic group is a combination of your carbonyl group and hydroxyl group. When you combine C double bond O to OH, when you combine what? C double bond O to what? OH. What you have there is what we call carboxylic. Am I communicating? Now, please listen. Any carboxylic group compound that contains more than 12 and above carbon atoms, they are referred to as what? Fatty acids. Am I communicating? And talking about fatty acids, generally speaking, one special reaction, one word, special reaction that alkanoic acids undergo is esterification reaction. What did I say it is? Now, what is esterification? Reaction between an alkanoic acid and alkanol. What is esterification? To give an ester and water. To give what? Ester and water. Reaction between alkanoic acid and alkanol. To give what and what? Ester and waiting and water. Literally, this reaction is reversible. And the reverse of this reaction is referred to as what? Hydrolysis. So you write the reaction is reversible and the reverse of esterification is known as what? Hydrolysis. What is the reverse of esterification? So you have alkanoic acid plus alkanol. Are you listening? What did I say it will give us? Ester and what? If the forward is esterification, what is the backward? Hydrolysis. The forward is esterification. What is the backward? Hydrolysis. Now, in your digestion of, fats and oil. You know your fats and oil? Do you know your fats and oil? You don't know your fats and oil, bah? Or you know it today. Fats and oil are esters. They are what? Esters, known as triglycerides. What did I say they are? Esters, known as what? Triglycerides. And when you try to digest an ester, it is digested, that's the fat and oil, sorry. When you try to digest the fat and oil, it is digested by hydrolysis. How is it digested? How do you digest fats and oil? Hydrolysis. Biology. Sweet to biology. Digestion of fats and oil gives what and what? Fatty acid and glycerol. What are you noticing? Alkanoic acid and alkanol. Am I communicating? Alkanoic acid and waiting. Alkanol is the product of oil. Acidic hydrolysis of what? Fats and oil. Did I say fatty acid? It's fats and oil element. Sorry. Acidic hydrolysis of what? Fats and oil. Can hydrolysis occur to fatty acid? No. What can be hydrolyzed are esters. Are you getting what I'm saying? Acidic hydrolysis of what? Fats and what? Oil. Leads to the production of glycerol and fatty acids. Acidic hydrolysis leads to the production of what? Glycerol and what? Glycerol and what? Fatty acid. What is glycerol? Propan 1,2,3-triol. What is glycerol? The IUPAC name of glycerol is what? Propan 1,2,3-triol. One of the uses of glycerol is that it is used as an anti-freezing agent, especially in your car radiators. Glycerol. Ethan 1,2-diol is also used. Am I communicating? For instance, I hope you know that trichloromethane, listen, is an organic solvent. But the one that is used industrially as an organic solvent is which one? Tetrachloromethane. So you can have the same use done by two different substances. Am I communicating with you? Good. So just have that in mind. I said trichloromethane can also serve as an organic solvent. Tetrachloromethane is also an organic solvent. But when you are asked which one of them is used industrially, the answer is what? Tetrachloromethane. Am I communicating with you? So the fact that, just have that in mind. So let's continue. Now, as I was saying, listen, acidic hydrolysis of fatty acids, fats and oil. What did I say to give? Fatty acids and glycerol. That is digestion now, no? Is it not digestion? When you digest fats and oil, what is going to be produced? So that means that digestion of fats and oil is as a result of acidic hydrolysis. Am I communicating? Now, when you come to alkaline hydrolysis, listen, alkaline hydrolysis of your fats and oil leads to the production of soap. Leads to the production of what? Soap and glycerol. Put that down. Acidic hydrolysis. What did I say to give? Fatty acid and what? Glycerol. Alkaline hydrolysis. What will it give? It will give what? Soap. Soap. S-O-A-P. And glycerol. Hi, God. Acidic hydrolysis. Acidic what? Hydrolysis. Okay, I've written that one, ba. Of your esters, what do we say it will give? Fatty acid and glycerol. Alkaline hydrolysis of esters will give soap and glycerol. The process is known as saponification. What did I call alkaline hydrolysis of fats and oil? What is the alkaline hydrolysis of fats and oil called? This is a question that will come out if you want. Acidic hydrolysis of fats and oil gives what? Alkaline hydrolysis gives what? They are not the same thing. That's why I'm separating them. You will see these questions. I told you that this is an examination preparation on organic chemistry. It is not your contemporary alkane properties. Please, if you want, write it. If you want, don't write. Let's continue. Now, I think I can leave that guy and then continue. So listen. Listen. I've already started teaching you naming. If you come to the Carboxylic Group, are we listening? The general molecular formula is CN H2N plus 1 COOH plus 1 waiting. You would have that N in this case starts from 0. Yes. N starts from 0. Using this general molecular formula, what did I say N starts from? 0. So the first guy which is metanoic acid, if we are to do it, it will be C0, is it not? H2 times 0 plus 1 COOH. C times 0. 2 times 0. 0 plus 1. So how many hydrogen? 1 hydrogen COOH. What is this guy? Meta. Why? It has how many carbon? 1 carbon. How many carbon does it have? 1. So the first alkanoic acid, according to this molecular, please, specifically, if you are using a different molecular formula, N will start from 1. But if you are using this general molecular formula now, where did I say N will start from? 0. Am I communicating? Good. So you have CnH2n plus 1 COOH, where N starts from 0. 0 means the first guy is met. The first guy is what? If N is 0, you have 1 carbon. If N is 1, you have 2 carbons. You will find that out as we are going on. Am I communicating? But then, I taught you something about naming. I said infix is number of carbon in parent chain. So where you have 1 carbon, what is it? Met. Now, the suffix has to do with the homologous series. If you see COOH, who are you talking about? So what is this guy? How many carbon? 1. COOH indicates alkanoic, right? So what is it going to be? Metanoic acid. Am I communicating with you? Good. Okay. So just have that in mind. Metanoic acid. Where N stands for 0. What else did I want to write? General structural formula RCOOH. Okay. Ester. If we talk about ester amine amide, we'll be done with that. Ester amine. I want to talk about amine amide because of primary amines, secondary amines, tertiary amines. Most of the questions you're going to be seeing have either to do with the lab preparation or identification of primary, secondary, and tertiary amines or quaternary amines. That's what I want to talk about. So listen. Now, an ester. Very important. How do you form an ester? Estarification. Give me an example of an ester. Fats and oil. Thank you. The functional group is COO without the hydrogen. COO without the hydrogen is the functional group of what? An ester. Another name of an ester is alkanoid. What did I say? Alkanoid. What did I say is the other name? Alkanoid. Now, one major thing about an ester is this. Are we listening? An ester is what is responsible for your fruity flavors. Are you getting? Your fruity flavors is as a butyl butanoid, for instance, banana. Anything that has banana flavor is butyl butanoid. A mixture of butyl butanoid and some other esters. Am I communicating with you? Good. But the major one is what? Butyl butanoid. Are you getting what I'm saying? So we have so many esters. And your fruity flavors, what is responsible is what? Ester. So just in case you come across it, you are not writing it down. Esters are responsible for fruity flavors. Esters are responsible for waiting fruity flavors. Oh yeah, let's continue. The general molecular formula of esters: CnH2n plus 2O2. CnH2n plus 2O2. N starts from 2, 3, 4, and so on and so forth. N starts from what? 2. CnH2n plus 2 waiting O2. CnH2n plus 2 waiting O2. CnH2n plus waiting 2O2. Hey, did I say plus 2? No. No. Sorry. CnH2nO2. I'm sorry. Yeah. It's not plus 2O2. CnH2nO2. Sorry about that. CnH2nO2. 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 Cn waiting H2nO2. Thank you. Now, The difference between your alkanoic acid and your ester is that if it is alkanoic acid, RCOO, what will be here? H. But in the esters, RCOO, another R. Am I communicating? RCOO, H. Here, RCOO, another R. So listen. Slightly, I'm going to shift a little bit out of organic and ask a question. Number 16. People that will write in Yamufu. What is the basicity of ethanoic acid? Why? The only replaceable hydrogen in the organic acids are the ones associated with the carboxylic group. It's not always one, no. COOH. COOH. This is oxalic acid, right? Ethandioic. Is this not ethandioic? What is the basicity of this acid? Why? The hydrogen you are counting is the one associated with what? The carboxylic group. Am I communicating? Replaceable hydrogen ions in organic acids are the ones associated with what? Carboxylic group. So 16. Iyamufu, when you come back, what I want you to use and thank me is motto. Is what? No. You know there is motto, there is car, and there is vehicle. Which one be the highest one, I beg? Car. Vehicle. Anyone. Anyone will not be this one they drive now. Don't buy. I'll collect. You're asking me what I'm driving. Okay. But if you buy me keke, I will still collect. Now, let's continue. Now, I just want to show you how to name esters. Yes. You see, I'm already talking about naming now. You that is waiting for naming especially, I have been talking about naming since the beginning of this class, so listen. Your unsubstituted esters. Oh God, listen. How do you name your unsubstituted esters? Very simple. Look at it here. Let's say you have something like a hen. Let me even show you how to write the reaction before I even talk about naming it. That's true. Because you could be giving reactions. That's our problem. We just keep concentrating on one part. Uncle, name it. Uncle, alkane. Uncle, alkene. And what will come out to now be reaction between an alkanoic acid and an alkanol. And they will give you the compounds and tell you what is the product. And you'll be like, hey, Jesus Christ. This man say he's going to teach everything. So listen. And you people were shouting what? Teacher do what? Teacher teach us. Now what can teacher they teach you go? It's